Okay, so today we're talking password attacks. Super exciting because you guys have all seen hashes or login forms that you're like, well, how do I attack this now? What are my next steps? And I was always like, wait, soon. So now we get to learn those attacks. I'm going to run through this pretty quickly because there was a series of videos to watch last night. So I'm just going to briefly touch on them and leave opportunities for if you have any questions about what you saw last night or any of those slides, and then quickly demo a couple of the tools before giving you guys some exercises that you can try on your own. So no talk about passwords would be complete without this XKCD comic. That is just fantastic. Just going to leave it up for a moment. And the only thing I will continue to say about this, because I'm sure you've seen it everywhere at this point, is don't use any password that has some combination of correct horse, battery, or staple on it, because I guarantee you it's on any good password list at this point, especially with security folks. Okay, so let's move on. What are we talking about today? We're going to talk about our general strategy for how we're going to attack passwords. We're going to do a quick review on hashing and different kinds of hash types. We'll talk about the different password attacking scenarios that we will find ourselves in, the different methods we have, and the different tools. We'll do a quick demo on those. Oops, why don't you come back? Cool. So password attacks, we're attacking authentication here, right? So can someone tell me what is authentication in your own words? Give me an example. Tell me, what is authentication? Take 20 seconds.
Who you are.
Yeah, it's so clear. It's the process of proving that you are the person you claim to be, right? And we use all sorts of different ways to do authentication, but the most common one is having a user ID and a password. That is the most common way that we can authenticate. And the insecure passwords make a whole bunch of security issues for us. So big ones are not changing default passwords. This is huge and something we encountered yesterday when we just logged in with admin. Always check default passwords. This is especially huge on all sorts of Internet of Things devices. So people have like all sorts of devices that connect to the internet now that have some kind of default password, and who's really changing their passwords to their refrigerators and things like that. Weak and easy to guess passwords are a problem. Hard-coded passwords you can't really change. You can imagine being a problem, and reusing passwords. We already saw a box where a user was reusing their password and we just tried it somewhere else. So these are the main security issues that we want to be concerned with when we're talking password attacks. Okay, so our strategy is going to be focused on retrieving password hashes and breaking those password hashes. So let's talk about what that actually means to break apart a hash or crack a hash. So we can look up default passwords for specific devices. We can read passwords from computer memory. We can guess easy passwords. And we can use combinations of brute force and dictionary attacks to break passwords. Okay, all of these are what's going to be in our tool belt for break-in passwords, right? Either reading passwords from memory, guessing passwords, default passwords, or using some combination of brute force and a dictionary attack. The other thing, of course, is reuse of passwords or using the same password for multiple accounts and multiple services. So what I want to talk about before we keep going on to passwords is biometrics. Right? There was a time where people thought we'd never have to memorize passwords anymore. We'll just put in our thumbprint or our eyes or use our face or our voice, and that will be our password. That'll be the way that we can do authentication and prove you are who you are. But how about we take 30 seconds here and think of some problems with this. What are the downsides of biometric authentication systems? Take 30 seconds and think about this. Shlomo, what's the downside of using a biometric authentication system?
Um, if somebody if somebody could, there's no way to really hide your biometrics. Like you can't hide your fingerprint. So if somebody gets to you, then they could just use your fingerprint.
Fantastic. So you lose anonymity here is, I believe what Shlomo is saying, right? You have someone's fingerprint, like you know who that person is now. You have someone's password, you don't necessarily know who that is. Awesome. What is another problem with biometrics as authentication?
Yep.
William.
Oh. So it's probably not just specific to me, but if I use a fingerprint, I rock climb, so it actually like wears away at my fingerprint. So
Biometrics change over time, and that increases the likelihood of false negatives, right? Your skin changes, right? Your eyes change. Any of these biometric markers can change over time, and then you get false negatives. They say that it's not authentic, not proof of authentication. I think, Dwayne, you were going to have something else?
Yeah, I was gonna say, I guess with the right type of ingenuity or technology, it can be replicated or duplicated or however you want to say it. To like if you just like you said, if you know the person or at least know who the person is, then if you were really trying to get into their stuff, you could like try to duplicate their fingerprint or eye or whatever.
Okay,
Uh,
so I'd,
or replicate it, I mean, and try to get in that way.
yeah, it's like some what was it? Mission Impossible? Is
Right,
that
right. I
one
was
of the
about to
movies
say,
where they do that?
I guess it's
I don't I don't
movie.
know of any cases where they have that technology yet, but it wouldn't be beyond me if there are ways of tricking some of these authentication systems.
Right.
Cool. So that's a whole bunch. Let me see. Any ones that we missed? Oh, if your biometrics get stolen, right? That's a huge issue right there. You can change your compromised password, but if your biometrics are stolen, just like Dwayne was saying, you can't change your biometrics now. Sharing. Sometimes sharing a password, while not secure, right? We're trading off convenience for security. Sometimes there are reasons that you might do that. You cannot share biometrics. There's never that possibility. And I guess the one other thing that I would mention about biometrics is there's a limited number of them. You only have 8 fingers, 2 thumbs, 2 eyes. There's not too many more. You only have one DNA profile. So there's only some limit to biometrics. So we'll come back to biometrics in Blue Team when we're talking about multi-factor authentication. But again, I just wanted to bring this up here while we're talking about authentication and passwords in general. Cool. Awesome discussion. So this is our main strategy for passwords is generating word lists, right? So first, we're going to learn how to generate some word lists. And the 2 main tools that come on Kali are Cool and Crunch. Cool, not pronounced Cool, but Cool, and Crunch, just Crunch. I'll show you guys how to use them. Cool is for generating word lists. So the whole idea is people are very bad at making passwords. And the passwords that people make are going to be very predictable, right? How many people have made passwords? Maybe you needed numbers in it, so you put in 1 or 2 numbers at the beginning or end of your password, probably related to your year, maybe the season, right? Maybe what it's a password to. And, you could just imagine people just make bad passwords. We're not very good at making them. And even if we think we're clever, when we substitute our eyes for exclamation points, we're not being clever. Everyone else has the same idea. So we can generate word lists based on information, and then using tools like Cool or Crunch, modify those word lists in such a way that we, generate a new word list based on our target. If anyone watches Mr. Robot, I think I want to say in season 1, he uses both Cool and Crunch to crack one of his friends' passwords, putting in like song lyrics and stuff like that, and grabbing words from songs that are of a certain length and like putting them all together and trying this whole list of passwords. That's the idea here, right? Okay, any quick questions on generating word lists? I'll show you guys how to do it in a bit, or at least the very basics of it. Cool. So same idea, right? People make bad passwords. We generate passwords based on personal data, right? So the starting point for our password attacks is going to be like knowing what are the requirements of a password, and then using that to generate a list. So for example, if we know that a password has to be at least 8 characters, and it has to have letters, and it has to have numbers, and it has to have signs, we're not going to add any password that doesn't meet those requirements on our word list, because it just can't, it wouldn't work. It would never work. Okay. So we need to know the password requirements so that we can generate a word list, an effective word list. Because all of these attacks pretty much are going to be based on how good our word list is. Okay. So a comment on brute force versus dictionary attack. I actually really like this slide, even though I think it's kind of blurry. I also think it's very clear. But here's the idea, the difference between brute force and dictionary attacks. Brute force is you're just going to try every single combination with no real intelligence. Whereas a dictionary attack, you're going to use some kind of intelligence from a word list, right? So we're using John or names, or some small substitutions like the @ symbol instead of a, right? Putting the numbers at the end like almost every other password people have. And so what we're going to do is some combination of both of these, really. We're going to use a dictionary, and we're going to change the numbers at the end or substitute different things, and generate really big word lists and use that for our password attacks. Cool. Questions between brute force and dictionary? You'll often see these terms kind of interchangeably, but generally we're talking about being a little smarter and using a word list, or a dictionary attack. Cool. Here are the things we got to watch out for. These are the kind of traps that the blue team has set for us as we are doing password attacks. So we need to be careful of rate limiting mechanisms. By that, I mean, how many times are you allowed to try an attempt to authenticate every, per unit time, right? Or how many times are you allowed to mess up your password per unit time? So usually it'll be like three attempts, and then you get locked out for a certain amount of time. So one technique that red teamers have to get around this is a technique called password spraying. And instead of trying a whole bunch of passwords on one account, you try a small amount of very common passwords on a whole bunch of accounts. Passwords like password or football or ninja, or some combination of those things. Like, if you know where the company is, maybe you'll look at their local football team and put those things in there, something like that, some kind of spray. And so this way you're under that threshold of being locked out, but you're still getting lots of attempts. You're kind of playing a numbers game here to get into that account. Cool. Any questions on rate limiting or account lockout? We've all experienced this, I think.
I have a rather odd question, actually.
Go ahead.
Those ransomware things where basically they ask you to pay the money and they'll give you your password.
Yeah.
Have the bad guys tried password spraying on their own accounts, on the accounts that they've locked out?
You tried password spraying on the account. Well, so so let me make sure I understand. You're talking about a ransomware attack where they encrypt your files, and you need the decryption key to unencrypt them. And you're saying, can we try a whole? So go.
Well, because so sorry. It's just I'm wondering whether or not like the bad guys have decided to spray the accounts so that when you try to hack your own password or hack the password so you can get your account back. I mean,
well, here's the problem. The decryption key is likely going to be very long and not guessable, whereas this password spraying attack is leveraging the fact that people use common passwords, right? So this password spraying attack is we're going to use a list of common passwords. Let's say we're going to try 5 different passwords for every account. And that way we don't get locked out of the accounts, and we don't get like IP banned because we don't hit that threshold, but we get to try a whole bunch of different accounts with these same passwords. We'll try like, Ninja, football, password, and ABC or something like that. And we'll try each account, one of those, and hopefully that's the password for one of those accounts. So I don't think this would work for, as a way to decrypt your ransomware. Does that answer that? Does that make it more clear?
Yeah, thanks. I was just wondering about that last night when I was doing the free work. Basically, it's like if your account has been hacked and you have ransomware on it, how can you, what is the least expensive way and the least damaging way to get your stuff back?
Yeah, I can't, like, once it's encrypted, there's that, like, you know, there's not really a way back unless you have the key, which is kind of brings us to here. Hashing, very related to encryption, or a subcategory of encryption. Well, let's do a quick refresher on what hashing is, how to think about hashing and hash algorithms. So I think of hash algorithms as kind of like a wood chipper. Maybe that's not the best example, but it's how I think about them. You put just about anything inside a wood chipper and you get some, just like some junk out, right? You get chips. So you can put anything inside a hash function and you get some junk out. The difference is in a hash function, you always get the same thing out, right? So if you put you know, plain text, some plain text A into a hash function, you'll always get the same hash text out, right? No matter how many times you do it. It's deterministic, okay? The other thing to know about hashes is there's no real pattern to the hash text, right? There's no way I can look at a hash text and be able to tell what it was originally. And in fact, very small changes in the plain text make a very big difference in the hashed text. And so this is useful to us. We can kind of use hashes as fingerprints. So you could take files, take anything, put it in a hash function, and look at the hashed text or digest. And if the if two different hashes, or if two hashes are different, that must mean their plain text must be different. So the important things to know are that hash functions are one way. We can't take hash text and reverse it. There's no way we can take a hash and go backwards. So you're like, wait, Matt, how does that make any sense? How do we crack passwords then? Well, we'll talk about that. We'll figure out how to do that. Databases should be storing their passwords as hashes, right? So they only have the hashed version of the password. They don't know what it was originally. Good hash functions should avoid collisions. A collision is when two different plain texts produce the same hash text. We don't want that. We want two different plain texts to produce two completely different hash texts, right? Everything should have different fingerprints, essentially. And good hash functions have high entropy, which means small changes in the plain text make a big change in the hashed text. And a good hashing practice or saving passwords in your database involves a technique called salting. We'll talk about what salting is in a bit when I do some demos. So password hash classes. Different algorithms produce different hashes. Sometimes in your journeys, you might find a hash and you want to attack it. So you'll have to find out what type of hash is it. And there's different ways we can recognize what type of hash it is or what type of algorithm produced the hash. One common way is just looking at the length. Different hash algorithms produce different hashes of different lengths. They'll always be the same for the particular algorithm, but the different algorithm will have different hashes. So let's reference this. This is that tunnel hash analyzer. Let's actually show you in here. So that's this hash analyzer. And what you can do here, it's just a GUI web app where you can paste a hash, click analyze, and it will do its best to tell you what it thinks the algorithm was that produced it. And it even gives you some examples, right? So MD5 produces hashes that look like this. They're always of this length. SHA-1 of this length, SHA-256 of this length. And there's certain things to the pattern that these hash algorithms are able to detect, or that these hash analyzers are able to detect. This is one way. Okay, let's get back to, cool. Let's talk about the two scenarios that you'll encounter when you want to attack passwords. The first one is offline or local. This is the scenario when you already have the password hash and you want to crack it. Okay. We have the hash locally on our file, and we're going to try and figure out what it was that hashed to this. The other alternative is a remote attack, right? This is a login page. What we need to be aware of with login pages is that we can try brute forcing them for sure, but we have to worry about account lockouts and stuff like that, right? We need to consider the defenses before we try this kind of attack. Okay, so we have brute force, which is guessing, trying a password, and comparing it to the hash. This is how we attack passwords. We have our password list. We have a hash. What we're going to do is go through that list, hash what we the guessed password, and compare it. Are they the same? If they're not the same, go to the next one. If they are the same, bingo, that must be the password. We can use this against salted passwords. It works for local and remote, and it's a small amount of time. I say small, computed at runtime. Should take a long amount of time. I guess small amount of space is what it takes. It takes a very long time, small amount of space. The other alternative is rainbow tables. So let's just talk about this one more time. Brute forcing means having a list of passwords that you guess, hash each password, compare it to the hash you have. Okay? So it doesn't take that much space, right? All you need is the password list and something that can hash each one and then guess. But it does take amount of time because it takes a certain amount of time to hash each password, right? It takes a certain amount of CPU clock cycles to do that. So that's one way. The alternative is what's called a rainbow table. This is where we sacrifice space to get ourselves some time. And you'll notice that it's very common in like computer science. We're always like balancing space and time. In this case, we're going to use some space to save ourselves some time. So the idea here is instead of having a whole bunch of passwords that we're going to hash each one and compare to the hash, we're going to have a giant database of already pre-computed hashes set up in such a way that we can like look them up. Right? So if we have a hash, we could say, hey, is it in this rainbow table? If it's in this rainbow table, well, this was the thing that hashed to it. So this must be there. Now, when I say rainbow table, this is a giant database. I'm talking like on the order of several hundred gigabytes to terabytes. When people actually go and bring these to live pen test scenarios, sometimes they're putting them in a big briefcase. Like it is a lot of data that it's storing here, right? Potentially extremely large, but it's very quick. So all you have to do is look it up in this table. It says it cannot be used against salted passwords. I will say that it makes it much more difficult because some people, it makes it much more difficult to use this against salted passwords. And Rainbow Crack is a tool in Kali. We're not going to be using it. You need kind of a lot of actual hard drive space to be building these rainbow tables. Because again, this is a giant database of hashed passwords. Okay. Important things to know about Windows hashes. Windows hashes in two different ways. So we have LM, which is the old way, pre-Windows 2003. It's a very weak hashing function, right? I'll even explain to you so you can see exactly how weak it is. It's converting the passwords to all uppercase and then splitting the password into separate strings that can only be 7 characters long and then hashing those. And it doesn't have to be a salt. So as you can imagine, this is not a secure way of storing passwords. So a while back, when Vista times, they came up with NTLM. I forget, Next Technology Network Manager, Next Technology LAN Manager. I forget what it is, NTLM. But that's the improvement. It's a bit better. And what does this mean for us in terms of PWK? No, wait. This is what I want to show you. This is what's important to us in terms of PWK. Why does it show you? Oh, interesting. this. So this is just a Windows password dump showing you the two different kinds. You'll see LM passwords. Here's what you need to memorize. LM passwords, they're always crackable. Every single time you find an LM hash and you confirm it's an LM hash by like copying the hash, pasting it into Hash Analyzer, and say it confirms it's LM. If you find that, know for a fact, truth, that is crackable. Use a tool to crack it, and we'll show you those tools. If you confirm it is an NTLM hash, it's not crackable. Give up on that one. The math says it's not in your favor in this universe. There's not enough time. Okay, that's the TLDR of NTLM versus LM. Okay, and then quick run through of the tools, and then let's demo these tools. So rocku.txt, we'll talk about this really quickly. Actually, why don't you use someone here? What is rocku.txt? Explain this one to me. What is it? Why is it on this list?
Isn't that a common, like it keeps a list of common passwords?
Yep. Rocku.txt is a list of common passwords. This was gotten from the Rocku Facebook group data dump or something like that. It is a list of the most commonly used passwords. Historically, someone found this database. This was the first time the largest password dump was found. I think this hacker scrubbed all the information and just publicly produced all of the passwords and how many times each one showed up. And this is when security engineers noticed most people use the very similar passwords or the same ones. People are very bad at generating passwords. And so as far as we go through, in PWK, rocku.txt is going to be our word list of choice for cracking passwords. If it's not on Rocku for PWK, then it's not meant for you to be cracked generally. I don't believe they have you do any boxes where you have to generate your own word list and use that. Cool and Crunch are the two tools for generating your own word lists. Totally check them out on the weekend, but we're not going to be generally using them in PWK. I'll show you what Cool does in a moment. And then we have the crackers here. John is short for John the Ripper, and this is going to be used for locally cracking passwords. Right? So if you have a hash, you can try a whole bunch of different passwords, hash them, and see if they see how they compare to the hash. Hashcat, same thing. It uses slightly different hardware. I think that generally works if you're working with a more powerful GPU, generally. I did some Google researching to see people's comparison between John and Hashcat, and I couldn't really find a big difference. So John's the one I'll show you, though. Hydra and Medusa, these are both very similar tools. I'm going to be demoing Hydra. They both essentially do the same thing. Slightly different syntax. And we have rainbow tables. You can check out crackstation.net. This is a fantastic resource where you can, this is essentially a giant rainbow table. You can put in a hash in here. It'll check its database to see if it already has that hash in there, and it'll tell you what it was that hashed that. So let's actually do that demo real quick. That might be the easiest one to do fast. Where am I? Close this. Exit. Okay. Cool. Cool. So let's hash something. Let's echo. I don't know what's a common word that's probably going to be in there. Volleyball. Right. No new line. Into MD5 sum. Right. This is the hash. The MD5 hash of the string volleyball. Don't want to, let's put it in Hash Analyzer first so you can see that. Okay, and it tells you it's either MD5 or MD4. Cool. So if I didn't know, if I just found this hash out in the wild, now at the very least, I know it's either an MD5 or an MD4 hash. Other thing I wanted to show you was CrackStation, where you can place a hash, just paste it right in there, prove that you're not a robot. Oh God, traffic lights. Crack hashes, cool. And it tells you what the hash was, what type it was, and it already had it in its database as volleyball. Cool. Cool. That's the first thing we want to show you. So let's go to RockU. We talked about it. Very common password list. If it's not on RockU, it's probably not going to be the way you want to go about it in PWK. In the real world, cool and crunch, though, to actually make your word list. So let's say we're attacking offensive security. Right? Let's say we're attacking offensive security, and I want to attack someone. I found one of their accounts, and I want to generate a word list of potential words that might be in the password. Let me, remove this demo and do this. So cool. -D, so you're telling it how many layers deep to go onto the web page. I'm going to go 1 layer deep, right? So how many links is it going to follow? -M for your minimum word length. So I want words that are at least 8 characters long. I think I'll leave -W for where you want to write this list to. So I'll just put it in root scrap. Offsec list dot text. That's what I'll call it. And I will send this copy. I think this should work. Oops. Paste that. Cool. Cool. We let that do its thing. We did its thing. And it's less offsec list. So now I have, and really all this thing did was make requests to that site, parse the text, and look for every word that has more than 8 characters. And maybe I would use these words in a password list. Maybe I would throw this word list into Crunch now and add some like characters at the end or at the beginning, right? Maybe replace O's with zeros sort of thing, right? Add more to make this list, you know, more useful to me, more useful, more likely to get a hit. Any questions on Cool for like generating a word list? It's cool. Again, you would use this word list now to pipe to Crunch. And if you want more, cool -- help to get your information here. Pretty simple to use. Cool. Cool. All right. So let's work with the crackers now, the more exciting stuff, what you came here for, the real weapons. So we're going to do a local password attack first on myself. And then we will do an online attack on my DVWA app. Okay. So let's do the local attack first. The tool we're going to use for this is John Ripper, soon as my computer wants to let me get access. There we go. So you do John -- help. And be honest with you, I use this tool pretty often, but I feel as though I have to fight with it almost like 40% of the time to get it to do what I want. So I'm usually looking through this help menu and the official page of John. And what I like to do, especially on their official page, is this John/doc/examples. And I'm always looking through the examples to see how how people are doing it to do specific things. Because I'll be honest, this one is a little finicky sometimes. Sometimes you have to specify what type of hash it is that you're cracking, what type of rules you're using, and the syntax is a little funny. So I always pretty much have this open along with playing around with the help menu when I'm using John. So to use John locally, I need some hashes, right? So I'm just going to use my own hash files. So let me see, John. Let's actually Google this first. John Ripper guide. I feel as though I used this. This is the documentation. Cool. This is the other page, right from the documentation, how to use. So if I use John -- help, what I need to give it, well, first, you got to give it a password file. To run John, you need to supply it with some password files. Optionally, specify what type of cracking mode you want to use. Now, in order to get a password file, what do those password files look like? There's a separate tool that comes along with John called Unshadow. Unshadow. So here, here we'll do head, Etsy password. Right, so here's my Etsy password file, just the top of it. You can see my users, and what does this X mean in the second field? You've seen this file before. What does this X mean?
That the user has a password.
That the user has a password, and where's the password stored?
Etsy shadow.
Mm-hmm. Head Etsy shadow. Right? So here, root's password is stored as a hash with all this stuff. I think it's salted too. Okay. So what I need to do is combine both of these files. John the Ripper works on files that are have both this stuff, but doesn't have an X. It has the whole thing, and it has all this stuff. So you have to unshadow. So unshadow -- help. Unshadow, password file, shadow file. This is probably the shortest help menu that you'll ever see. Okay, I can do that. Unshadow password file / Etsy passwd / Etsy / shadow. And I'm just going to leave this as unshadowed. Okay. And just so you can see what unshadowed looks like, it's nothing special. I should just head unshadowed, sorry. It's just the combination of those things before. Right, it's just the combination. It just took the hash part and put it in there. John the Ripper is now ready to go with this stuff, with this file. Okay. John -- help. Well, here, we can do this. We can either just give it the password file, or we specify a word list. So that's what we're going to do. John -- word list equals, and what word list am I going to use?
Rockyu, of course.
I'm going to use Rockyu, of course. User, share, word lists, Rockyu.txt. Okay. And then you could specify rules. I'm not going to do that. I'm just going to give it the password file. And the password file I called unshadowed. Oh, it's not exciting. I should have said -v for verbose. You could set it so that you could see it as it's doing. Let's see. Loaded 3 passwords with 3 different salts. Did it run? John -- show unshadowed. Okay, this is how you actually view. So you can see I made a couple of extra accounts on this machine. I made Bruce, whose password is Batman, and I made Peter, whose password is Spider-Man. Both Batman and Spider-Man, not very secure passwords. They're on Rockyu. So that is all I needed to do. Now, this happened to work very nicely, but sometimes you'll have to specify some specific rules or options or what type of hash you're working with here. So you might have to fool around, and that's, like I said, I pretty much always have the usage examples open just because I often need to check them out. Cool. So that is locally cracking my passwords, right? Use a password list, hash them in the way that these passwords are hashes, and just compare the 2 hashes. And if they're the same, we got it. If they're not the same, you just keep checking. And if it's not on the list, that's it. It's not on the list. Okay. It also got root. Still default tour. Questions on local password attack with John? Okay. Hashcat's the other tool. I'm actually not as familiar with it. Oh, do I not have? Is it not installed on this? Could have sworn maybe. Maybe it's not on this version. Could have sworn maybe it's on your version. Check yours. Could have sworn under password attacks, Hashcat's here. Maybe not. Maybe not on my version. Huh. All right, cool. So then let's finally show you using Hydra to attack an online form. Okay. So I'm gonna go here to my damn vulnerable web app. I'm actually gonna go right here. Log in. Gonna make sure that I'm on low security, and we're gonna go to brute force. Okay. So this part of my web app is specifically for me to practice a brute force attack, right? So what you always want to do is first manually attempt things. Okay. So I know the user I'm trying to break into is admin, and obviously I already know my password. But I'm going to just try a password that doesn't work and see what happens, right? If I try it and it doesn't work, I get something on the screen that at least tells me that it doesn't work. Okay, and just so you guys see, I already know the password it's saved. If it is the correct password, all it does is tell me, welcome to the password corrected area. Other apps might let you go to another area. All this one does is that, if I put in the correct password. Okay, so that's what I want to do. At first, I want to test things manually with my browser, just literally trying it out. The next step is I want to look a little bit deeper. I want to actually examine the requests and see what's happening beyond what I can normally see with my browser. So the tool I really like to use to do that is Burp Suite. Okay, so let's get Burp Suite set up. You can go to About, Preferences, scroll on down, make sure you have your proxy set up. Port 8080, that's the Burp proxy I'm using. I go over to Burp, and I'm going to turn Intercept on. So I will catch all of my requests, and I can look at them before they go out. All right, so I'm going to put in admin and a password, and I'm going to hit login, do an update, and it gets caught and sent. That is not that. Forward that one. Let's try that again. Login. Why am I not catching this now? Why am I not catching you? Proxy on. Let's close these. It is catching something. Let's close these. Should catch it here. All right, let's turn Burp off and turn it back on again. Live troubleshooting. We're not updating. Yes, start Burp. Okay, proxy, options, intercept is on. All right, how about you actually catch this now? Interesting. All right, looks like it's catching some of them now. Trips is on. Go here. 1, 2, 3. Again. There we go. All right. Turn it off and on a bin. Amazing. Genius. Okay. So here we go. We have our request. I like to bring it into Burp just so that I can play with it a bit more and see all of the details. I'm going to hit Control R, and that sends it over to Repeater. So I like Repeater because I can I have the request right here. I can edit it how I want, and I can keep sending it and seeing what the response actually is. So let's take a look at this. Apologize, I don't think I can actually make it larger, but here the important things we see are the host, right? That's just the IP address of the machine. We have the GET request going to /dvdub vulnerabilities /brute. And then we have these query parameters here. Username equals admin, and password equals 123, and login equals login. The other things I see here is there's a cookie being set that says security equals low and PHP session ID. We know what session IDs are. Cool, that's how we stay logged in, right? Okay, cool. So I have all of this information. What we're gonna do now is, again, manually take a look at what's happening. I send it. All right, I tried password 123. We're gonna look down and it says username and password is incorrect. Okay. Let's try 1, 2, 3, 4. Oh no, 1, 2. Yeah, 1, 2, 4. 1, 2, 4, send. And add is not the password. Okay. 1, 2, 5. Send. And we still get the same thing. Username or password is not correct. Okay, good. I want to repeat this a few times, and I want you to kind of do this as well so that you can kind of see like, well, what am I really doing here? I'm making a request. I'm changing a parameter in that request. And then I'm looking at the response for a particular thing. And based on what that thing says, I either keep going or I know I'm logged in. This should sound really familiar to code you have written before, right? Keep making requests, change a parameter of the request, look at the response. If the response has a particular thing in it, keep going. If not, do something else, right? We've written code that does this. We're going to now use a tool that does this. It's important that we do it manually first so that we know what it is we're doing and what it is the tool is doing though. Any questions? Okay. Cool. So let's use a tool to do this. To automate sending request, changing only one of the parameters really, right? Changing this password equals parameter and doing something based on the response. The tool we have for that, the one that I'm going to demo for you, is Hydra. Okay. Let's look at Hydra. Hydra -- help. Oh. Hydra -H. Cool. So we scroll to the top and you're like, holy moly, there's a whole lot of options going on here. And you're right. Hydra is frankly a tool that you need a lot of practice with. And if you don't practice with it often, you're going to find, I don't want to say you struggle with it, but you definitely have to like, the syntax is finicky. And there's a lot of things you have to put in here to get it to work properly. And you'll have to do some troubleshooting too, because sometimes, I know very oftentimes, if you said it wrong, you're going to get a whole bunch of false positives. It's going to say, this is the password. And you try it and you're like, wait a minute, no, it's not. Or it's going to tell you this is the password. And like all of these 16 things are the password. And so we have to do very careful thinking, what does this tool do so that we can do our troubleshooting for it? And remember, what does this tool do? For us, it's going to be sending requests, changing a parameter in the request, looking at the response, and doing something based on that response. It's a very stupid tool. It's just going to automate what we're doing right now. Okay. So the other thing I would recommend while you're using Hydra is, let me turn off proxy right now so I can browse, is go ahead and take like Hydra examples, especially depending on the service you're looking for. Look, you could even see I go around to these examples pretty often. But let's take a look at the actual page here so we can read through it. So here's the syntax. You give it Hydra. You do -L for what you're logging in as. Lowercase l if it's the same login you're going to use every time. I got to fix that. So you're going to use like the same username, like admin. That's what we're going to use every time. So it's lowercase l. Alternatively, if you have a whole file of usernames you want to try, you'll use uppercase L and give it a file name. Same idea here with passwords. You either -lowercase p if you're going to use a single password that you want to keep trying, or -uppercase p if you have a whole file of passwords you want to keep trying, right? So we're generally going to use uppercase p with RockU. That's our password list file. I think -C file is for combination, and that's when you'll see passwords that are just like username : password. You'll see password dumps like that sometimes online. I think I showed it to you guys before when I was doing like some Google dorking and found passwords. You sometimes find them in that order, just like username : password. -T for tasks. I think you could use that as like threads to go faster. Don't really use most of these. But then this part's important. The service, and then how to interact with that service. And this generally is where you're going to have to Google depending on what the service is. Okay. So the other thing I want to show you down here at the bottom is you can use Hydra not just for brute forcing web login. You can use Hydra for brute forcing FTP, right? You can use Hydra for brute forcing IMAP. You can use Hydra for brute forcing POP. Use Hydra for brute forcing SSH, right? Hydra is a very versatile tool. But essentially, what does it do every time? Try and log in. And if it doesn't log in, try a different user or a different password. So robust tool, but a very stupid tool. Okay. So let's take a look at what we got to do here. We need to send that request. So let's look at it in repeater. Okay. Get my terminal open here. Scroll up to the top, and this is the format. We're going to do Hydra. I'm not going to forget this time. I'm doing V and uppercase V, super verbose, so we can watch it try every password and feel like really cool hackers when it fills up the terminal. So that's exciting. -L for what user, right? So that was admin. That's the username we want to use. -uppercase P for the password list, which is user, share, word list, RockU. Okay. We need to give it the host that we're going to attack. So that's 192.168.40.197. Cool. Give it that. And now we need to tell it what, let me show you. Hydra-H. We need to give it the service that we're attacking. So you see here has service, : and some information, and the options. So what does that look like? Services, where's the list of services? Here are the different services we can attack. Okay, so Atom 6500 is a type of service. Cisco services, right? We'll see MySQL or MS SQL, MySQL, right? These are different services we can log into. SOCKS, SSH, right? The one that we're going to be using, if you look here, is a HTTP GET, right? This is a GET. It's kind of weird in this case that we're using a GET to log in, but sure, you can use a GET to log in. Usually it'd be a post, and the username and password would be inside the body. But in this case, in this particular app, we're using an HTTP GET form to log in, right? It's a GET request. Here's the information for it. So it's an HTTP GET, or is it HTTP GET form? HTTP GET form. Okay. So let's say what it is. HTTP get-form. Okay. Here comes the hard part. Not hard part, I want to say, but definitely a part that I personally screw up very often. You need to give it all the options that this form needs. And they are separated by colons. And I generally have to look them up. So I'd look up like HTTP-get form Hydra for the parameters. And so we need to go, where are we trying to hit? What is the endpoint? It is this. It is /DVWA/vulnerabilities/brute. Right? This is the endpoint. So I'm just going to copy that. I just do copy and pasting for this because otherwise I'll screw it up. And paste. Right? That's the first thing. Right? This is the part of the request that it needs to do. It's like hit this IP address /DVWA/vulnerabilities/brute. Okay.
Sorry, just a heads up, the IP address is wrong.
Thank you. 192.168. Huge. Cool. All right, so that's the first thing we need there. Next thing we need is the data we're going to send, which is this. So I'm just going to literally copy this half of it. Copy URL. No, not copy URL. Grab this text. Copy that text. Paste that text. And the only difference here is instead of admin, I want this to say caret key user, caret key. And instead of this password being 125, it's whatever I want that password variable to be. It'll be PASS, caret key. Where does user caret key user and pass caret key pass come from? This is the syntax of Hydra, right? This is saying we're going to send these requests, and where it says user, we're just going to fill it in with this L. So it's just going to be admin. It's going to be admin every single time. But where it's pass, we're going to use what we get from user share wordless RockU. Right? So this is where we're injecting those passwords in there. Okay. Not done yet. I got to put another colon. And if you remember back when I was doing this manually, I have to look at the response. And I have to look for something that tells me this is a failed response. And so what I look for in the response is the thing that tells me that I failed. And it's this string, username and or password incorrect. So I'm going to copy that. Copy. And paste. Gosh, I'm almost done. There's a little bit more I need to add to this request to get it to work. Does anyone see what else I need to add into this request? So what other data I'm sending? Can I make this larger? Can't. Look at my request. What am I sending inside Burp, but I'm not sending inside Hydra right now? Oops, that's not what I want to share.
Your session ID?
Yeah, I'm not sharing the cookies. Not sharing the cookies in this case. Okay, cool. So you look up how to add the cookies. It's this, you colon, header, H equals cookie, colon, and then you just give it the cookie. So I just literally copy this, copy, and paste. I'm actually not going to do the cookie first because I want to see you guys to see this fail and do some troubleshooting. So I'm not going to put the cookie in there yet. So no, this is not going to work. So let's try it. Cool. Super verbose. This is what I'm telling you. So I did it super verbose so we can see every single attempt, right? So here's one of the first attempts. It tries login admin, pass 1, 2, 3, 4, 5, 6, right? tries 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are just the top of rocku.txt. We're just going through it and just sending those requests. You'll notice here in green, this is telling me that it was successful, right? No way all of these passwords are successful. So we got to use our brain and do some troubleshooting here and remember how this tool works. All this tool does is look at the response and see if it says username and or password is incorrect. If the response doesn't say that, it's like, oh, that must be the password. Obviously, these are not all the password. So what we did wrong was we did not add the cookies. So I'm assuming what happens is we sent those requests and it didn't have the cookie. The response that came back was like, didn't have this in it because it didn't have the cookie. It didn't know where we were at. There was no state. So when you encounter this and it shows you a whole bunch of passwords working, that means something is going wrong. It's not all of these passwords working, right? A little troubleshooting. We go back. Let's now add that cookie. H for header equals cookie. And then let's paste the cookie in there. Copy. Paste. And like I told you, there's a whole bunch of stuff I have to write in to get this command to work. I'm telling you, like this is a very common command to screw up. Very, very common tool to screw up using, and you're gonna have to do your own kind of troubleshooting on what's going on wrong. Like if I see something like this, I'm like, ah, I must have done something wrong. Okay, so let's hope that it works correctly now. Ah, this is what I like to see, right? Only one password worked. And you could turn off the -VV if you want, so it doesn't completely ruin your terminal and you get that. But you know, sometimes I think that's fun. And so now this is confirming. I can log in with admin and the password is password. So let's actually go try. Make sure that's off. We're gonna go here. Password. Cool. We get to log in. The other thing I want to tell you as you're doing your troubleshooting, sometimes this won't work and it won't load. It might not be that your command is wrong. It might be that there is something on that system that prevents you from logging in so many times or prevents you from trying to log in so quickly. Right? So I want you to be aware these types of online password attacks are kind of loud. Right? It works in PWK because no one else is really listening. But just know in the real world, these kinds of attacks are generally kind of loud. You're banging in and trying everything. But do be encouraged to try it out in PWK. That's the point. Okay, cool. Questions on using Burp to do my investigation or Hydra to actually automate sending those requests? I'll show you on screen what the command I ended up running was. And I'll even paste it in Slack. Take some time, think of questions. No one has any questions? Are people excited to use these tools to start cracking some passwords now? I don't know. I remember when I first learned those tools, I was like, this is so cool. It's like, let's break into stuff now. So let's put this in Slack.
I have a question.
Yes.
Throughout talking, you'd mentioned occasionally having, if we have the hash, etc. How difficult is the hash to come by? Because I'm assuming like the calculation or whatever, the algorithm's on the server side. So how would you come across that? And is that a frequent thing?
Okay, so how often is it do you come across hashes?
If you have like having the correct hash, I mean.
How often is it that you have the correct hash? Or how long do these attacks take, I guess? Depends is the answer. Sometimes these can take a long time. Right? Because if the password's on Rocku, but if it's at the end of Rocku, right, it's got to go through every single one. It's got to go through the operation of hashing each one of those passwords, comparing it, and then, it'll be at the end. I know for the examples I've given you, I've used passwords that are kind of at the top of RockU. So it shouldn't take too long for you to actually run them. Does that answer your question of how long does this take?
No, not really.
Okay, I'm sorry.
So I'm a red team hacker, and I'm trying to get into this system, and they're not storing their passwords plain text. They have them hashed and in a list. Now, for me to, on my end, run a rainbow list and get a hash that compares to the one they have, I would have to have the hash they have. Do you know what I'm saying?
Yeah. Oh, so exfiltrating there. So like you get onto a box, then you would try and like look to exfiltrate like Etsy password and Etsy shadow, right? Like, can you read those files? If you can read those files, maybe use Netcat so that you can use them to transfer to your own machine, then locally attack them. Yes, for Windows specifically, there's a couple of tools. I think FGDump, your book mentions, for dumping passwords from memory, dumping the hashes from memory. And then once you have those hashes, you save them to a file and then do some of your offline password cracking. Does that answer it? Like, how do we actually get them? Yeah. So once you finally get a shell, right, it's the whole part of recon starts again. What files do I have access to reading? Can I read Etsy password and Etsy shadow? And like, now I have perhaps a way to get user accounts, different user accounts, and we move from there. Great question. Yes, that's how we'll find them. Cool. Is there anything else I wanted to show you? I sent that code in there. All right. So what are we going to be working on then? Let's show you. We're going to be working on, for this morning, where is it? There we go. Go down here. Down here. All right, so here's the content for this morning. Right, we had Corey's videos for last night. You can review them if you'd like. But we have two main activities for this morning before we go on to box work. It's going to be offline password attacks, so very simple stuff. Here you got some hashes, crack them. Here you'll have these two files, figure out what to do with them, as well as online password attacks. So just so you get an idea here, I made this instance of this Google Gruyere app here. And you'll try and sign in as the user Karate Fish. Karate Fish 3. You'll try and log in as this user. Try and get in as him. I've made that user the password somewhere on RockU. Figure it out. I think I added Frank on there too. So if you figure out a Karate Fish, also hack Frank. Some user named Frank. So those are going to be your exercises for this morning. If you finish early, the box that we're working on today is core. Core is the box for today. So that's just what we'll do if you finish early. And then essentially we'll just, that's all we have for the morning. Any questions? No? All right. In that case, go ahead, take 7 minutes. So I can set up the breakout rooms, open up the workshop, and get to it.